Voyager 1 was launched on September 5th, 1977, heading for Jupiter, and reached the planet on March 5th, 1979. If the average distance from Earth to Jupiter is about 390 million miles, how long would it take Voyager 1 to reach Jupiter at the following speeds? So, what we're going to be dealing with here, guys, is we're dealing with distance and rates and times. So that's what we're looking for. They want to know how long. So, when we hear distance and rate and time, think of our distance formula. Distance equals rate times time. Now, it wants to know how long, so we want to know the time. We could plug things in and solve, or we could just manipulate the equation. That way we don't have to solve an equation for every single one. It's kind of a bonus of manipulating our formulas or solving for a different variable. Now again, I'm interested in time, so let's solve for t. If I'm solving for t, I have to get rid of r. Since it's r times t, I'm going to divide both sides by r. What we end up with is our time equals distance divided by our rate, or our speed. So let's use this formula. Time equals distance divided by our rate to figure out how long it's going to take for each one of these speeds or rates. So for the first one here, it wants to know how long it would take Voyager 1 to reach Jupiter at 30,000 miles per hour. So our time will equal our distance. Remember, our distance was 390 million miles. So that's 390 million, that's distance, and our rate, our r, is 30,000. So if you were to type that into a calculator and divide it out, that would be 13,000 hours. Okay, the reason I know it's hours is because remember this is in, the distance is in miles, and this is in miles per hour. So if we were doing a unit analysis, we would see that our miles canceled out. Okay, or again, if you're talking about time and you set up the equation correctly, it makes sense that our equation is done in hours. If I'm interested in how many days that is, remember there are 24 hours in a day, so we could go 13,000 and just divide it by 24. If you divide that by 24, you'd get a decimal, but it's approximately equal to 542 days. Now, let's try it with this one. Our distance is still going to be 390 million miles, but this time we're traveling at a speed of 40,000. If we divide that out, we get 9,750 hours, and if we divide that by 24, we're going to approximately 406 days. Again, instead of having to solve an equation every time, we manipulated the formula once and now we just plug numbers in. If we are traveling at 60,000 miles per hour, we take our distance and we divide it by our rate, 60,000 miles per hour. And that would equal 6,500 hours, which, if we divide by 24, is approximately equal to 271 days. Now, if we look, this last question says, what is the best estimate of its speed? Look here. We went from September 5th, 1977 to March 5th, 1979. So, if you think about it, from September 5th, 1977 to the next year, September 5th, 1978, that's approximately 365 days, right? Now, if we go from, that's how many days in our year, and if we go from September to March, now let's see, that's, excuse me, September, October, November, December, January, February, March. That's about 6 months, okay? 6 months, just on average, if we took an average of 30 days per month. If I went 6 months times 30 days, that's going to be 180 days. So if we had 365 to 180, and I'm sorry this is all being crammed in here, we would get 545 days. Okay, so we know the trip took approximately 545 days, not exactly. We know the trip took that long. About how fast are they going? Well, we have three choices here. 30,000 miles per hour, 40,000 miles per hour, or 60,000 miles per hour. We know it took 545 days approximately, which is pretty close to this right here. So what is the best estimate of its speed? 30,000 miles per hour. Okay, again, be careful because it looks at first like you don't have enough information to solve this, but it did give you dates. So kind of just think through the question and try to make your best estimate based on the information given.